All right, I think we're good now. Let me see if I can zoom in just a tiny bit more over here. Okay. Um, so students should have been taught by their teacher before this lesson about unit rates, okay, and proportional relationships. But just in case, okay, I would like you guys to go over unit rates and kind of merge it into writing an equation, which is what they've asked us to cover on these days. We need to cover writing an equation and graphing proportional relationships to identify the constant of proportionality. So, the constant of proportionality is the constant rate of change that you see with a set of data. So, say you're talking about going to the grocery store and buying apples. You know, each pound of apples costs a certain amount of money, and no matter how many pounds you buy, that cost stays the same per pound. Whereas, say, actually on Amazon, like when you're buying one or two items, it might cost a certain amount, but then as you buy more, they start to give you a discount. Okay. So, because as you buy more, the price is changing per item, that means that that would not be a constant relationship. So, it wouldn't have that constant of proportionality. Also, when we're talking about constants of proportionality, um, we have to talk about the fact that there's zero zeros. So, for instance, when we did these worksheets, okay, we everybody had 0 0, okay, because in this case it would be if I have no logs, I would have no hours of fire. Okay, if she had no meters of the metal bar, there would be no weight. All right. So those are important parts of this. I would start off this section by asking them what they remember about unit rates to see how much you're going to need to talk to them about it. Because again, the teacher should have previously gone over the unit rates, but we really want to make sure that they've been able to master this objective. And so we're going to go through these worksheets and also write an equation to represent the constant of proportionality. Okay. So on this worksheet, it says write the rate and unit rate for each phrase given below. I'm going to edit this a little bit to also add on the students to write the equation for the constant of proportionality. Okay, so my rate, right, is going to be 80 inches, okay, of snow per 10 days. So that's the information that they give me. So that's the overall rate that I've been given. My unit rate is per one. Okay. So instead of in 10 days, how many would it be in 1 day? Well, they could go over and do the double number line. And we would say 0 0. Okay. I know that there was 80. My units. In 10 days. Okay. I could then break that down and I could say, okay, well, half of that would be 40 inches in 5 days. Oh, halves, that'd be 20, but that'd be 2.5. So that wouldn't really help me. Um, what if instead I broke these down into like five equal sections? One, two, three, four, five. And so 1, 2, 3. Right? We did this one on the previous video. So 40 divided by 5 equals 8. Okay? So I have 8, and I could actually just stop there. I wouldn't need to put in all the rest of the values. Okay? Because in 1 day, I would have 8 inches of snow. So my unit rate is 8 inches of snow per day. And that indicates per 1 day. Now, when we add in the constant of proportionality equation, okay, this unit rate is the K value, all right? The per one is going to be your constant of proportionality. Okay. It's going to be k equals 8. So then my equation would be y equals 8 times x. All right. Because I didn't give them variables to use, I didn't identify. We would just use the x and the y. Okay. If you wanted to have them identify snow being s and d being days or something like that, it would be fine. But x and y is what we used to use generically. And then I can have them show how this is true if they've used the number line here. I could say, okay, well, in one day, well, 8 times 1, that's here. Okay. Well, 8 times 2 is 16. Okay. And then I could also go and check my larger values here where I broke it down into the halves. And I could say 8 times 5 is 40. Oh, look. Okay. That's proving that my values are matching my equation that I just created. Okay. And this would be my equation. The next one, the 3 comic books for $3. Okay. I would say that my rate is 3 comic books, or they could write 3 books per $3. Most teachers are okay if they just put the dollar sign. So then again, my unit rate, I could do this double number line, or the students could simply do division. Up here, you would say 30 divided by 10 is 8. Here, it's 3 divided by 3 is 1. Okay? And it's 1 what? I can get 1 comic book per dollar. Comic books are on top per dollar, money is on the bottom. It's important that they write this out. Don't let them just write 1 here. Again, I'm going to add these lines in just a second. I wanted to make sure I got this video up for you. And have them write out k equals 1. Then my equation would be y equals 1x. I understand that traditionally we wouldn't write the value 1 there, okay? But we do want them to understand that that's where the k goes, is right in front of that variable, right? I would like you to pause, okay, and work out these problems. You're going to upload them to your Canvas page, okay? But if you want to pause, I'll do the next one to make sure you're on the right track. Okay, so I would say my rate would be 5 pounds. You might also go over the abbreviation LB as pounds because some students don't understand that, of potatoes for $10. Right? Well, if I do 5 divided by 10, that's going to give me 1/2. So I'd have 1/2 pounds per dollar. Okay. Now, would 1/2 pounds per dollar make sense to most of our kids? I would say probably not. Okay. So what I would do is I would switch this around and I'd say, well, we can also think about this as if the cost is $10 and I get 5 pounds, I'm going to abbreviate it this way. Okay. Then 10 divided by 2, and my cost would be $2 per pound. Okay. These are both correct. All right. It just matters what they want to know and which values would be on the x-axis and which values would be on the y-axis. Okay. This would probably make the students feel more comfortable that the potatoes cost $2 per pound. And so I would stick with this. Okay, so this would be K equals 2, and my equation would be Y equals 2x. Okay, in this equation, K would equal 1/2, and my equation would be Y equals 1/2 x. But we really don't want to deal with the fractions right now. We want to go for whole numbers because this is a little bit different than this. Okay. Um, and so I would be careful, and the kids will get a little bit more confused because they're going to be used to seeing things like this right now. All right. So again, you're going to upload these answers here, okay, to your Canvas page. And again, I'm going to edit this so you'll see a little bit different one online. Okay. We then go into an additional unit rate page. It just has more challenging values. That's all. Okay. So 72 cups of yogurt in 2 cartons. Some of your students might not need an additional page, but I want to provide that for you guys so that you just have extra practice if somebody needs it. And remember, if they want to do more, they could take their worksheet home and bring it back to you the next day. But they're not required to do homework for us. It's just if they needed to do more, you have that, and you're able to kind of give some students a little bit more guidance than other students. Okay. Um, this one, again, I would ask you to make your answer key for it. Okay. And I will add in the extra parts about the K. All right. Then we get to here, and we need to talk about comparing proportional relationships. Okay. The students will need to know which proportion is greater or less than the other values. And so this is a really good worksheet on doing that. So to compare proportional relationships in each problem, they first need to be able to find K, the constant of proportionality. Again, they should have done some of this with their teachers prior to you walking into the classroom, but assume that they haven't or ask them what they know before you start teaching them. Some of your students might grasp onto this really quickly, and others may not. Okay? Again, in a constant of proportionality, we're going to talk about that ratio first and see if there's a common ratio. If there's not a common ratio, if one value throws it off, then you've got to stop and say, oh no, that is not a constant relationship. So here, okay, it says Sunny Orchards charges for fruit by weight. The table shows prices for apples, and the graph shows prices for pears. So we have apples and we have pears. Okay. This is a table. This is a graph. Okay. So this first one says, what is the cost per pound of apples? So they want cost per pound. So my cost needs to go on top. I have 15 divided by the pounds. And I'm simply going to work my way down this table. Again, if they wanted to use a double number line, they could do that and work their way back to 1. But hopefully these values are going to be pretty straightforward, and they should be able to use the division. So 15 divided by 5 is 3. I have to check all the other values as well. So 8 divided by 6, right? The cost divided by the weight, that's 3. And I'm going to have to go 21 divided by 7. It's 3. 24 divided by 8 is 3. So my constant of proportionality is the same the whole way down the page. So you would be able to say, all right, K equals 3. Also, the cost per pound of apples is $3 per pound. And you can either use pound or the LB. Sorry, that's hard for you to read there in the gray. right? For this graph then, okay, they want to find the same thing. Students understand slope at most of our school sites with most of our teachers because they're in an additional math class at one of our school sites. They have done slope, okay, so they might use that. Otherwise, okay, the cost per pound, okay, we're going to do cost on top, right, and weight on the bottom because it's cost per pound. So this is the top, this is the bottom. And what I can do is I can pull numbers off of this graph. Okay. They're probably not going to go for 1 in whatever's here because it's not a given value. They're probably going to start here at 2 and 5. Okay. So I can say the cost at $5 for 2 pounds. My cost is $10 for 4 pounds. My cost is 15 for 6. And my cost is 20 for 8. Okay. And you would probably ask them to check multiple data points. Okay. Then they actually do need to do the division. All right. So if we say $5 divided by 2, well, that's going to be $2.50. 10 divided by 4, well, I would say, okay, well, 10 divided by 2 is going to give me 5. Then 5 divided by 2, and back here is $2.50. Then hopefully they start to notice a pattern that these are all changing by the same amount. Okay. For the same amount that I increase my price, I go over the same. For I increase my price by like 2 humps is what they'll probably say. I go over 2 humps. All right. And they'll notice that that's actually slope, rise over run, and that all of these are $2.50. Okay. So my constant of proportionality is $2.50. So which fruit then is more expensive per pound? Well, the one that's more expensive is going to be the apples because it costs $3. And the next problem says Sam's Club Deli sells deli meat by weight. The scale shows one customer's purchase of ham. The table shows the cost for common weights of turkey. So this is a scale. 2 pounds of ham are $14. So what's the cost of per pound of ham? Okay. A lot of them, when it's divided by 2, can just tell you. So that'll be $7 per pound of ham. But I would ask them to write it out again. Cost per pound. So my cost is $14 divided by my 2 pounds. So 14 divided by 2 is $7 per pound. And again, you can do pound as LB, or you can write out the word pound. Here then, okay, the weight of turkey and the cost. They want to know cost per pound. So it's going to be this value here, 1350 divided by 1.5. Okay. So I have 1350 divided by 1.5. Okay. The students are probably not going to have calculators still. So you are going to need to do some of this by hand. I would probably go to the 18 and start with that one first and say that that's $9. And 27 divided by 3 is also 9. And then go back and do these half pounds. Okay. In this case, it might also work out better for them to draw the double number line because you have these half values. So they might be able to see that instead of going up by a whole pound, if I went by half, instead of going up by 9, well, what's half of 9? Half of 9 is $4.50. And so they can find the values that way. Okay. So our cost per pound of turkey is $9. I have no clue why sometimes I write the 0 cents and sometimes I don't. But make sure that they understand that those are the same thing. Here we've got the question, which meat is more expensive per pound? What looks like our turkey. Okay. So what I want you to do again, just like the other sheets, is you're going to do an answer key and you're going to upload this page. You're going to do the back, okay, and upload those pages. And again, you might not use all of these for all of your students, but depending on their level, you might want to. All right. Um, Next, you'll go into actual graphs and talking about the proportional relationships that we see in graphs. As you can remind your students here, as we were changing by the same value each time, okay, these were proportional relationships. Okay, we changed by the same values here, and on our other papers, we've gone by the same values there. So when we're talking about graphs specifically and identifying proportional relationships, okay, we need to be able to determine if each graph is proportional and how you know or how you don't know. Sorry, my recording did something weird all of a sudden. So if you're going to be doing these worksheets, okay, which they need to know, I would review again what they know about a proportional relationship, which is they're changing by the same amount the whole time. Okay? They're changing by the same amount the whole time. So if we look at these graphs, okay, it says, does the graph show a proportional relationship, and explain how you know? Okay? All right, I had to fix an issue there. All right. So on identifying proportional relationships, they have to have that constant rate of change. Okay. And again, a lot of them know about slope, some of them don't. Okay. So what most of these students are going to say is like, oh, that's a line. Okay. Get a little bit more out of them. It is a straight line. We call it linear. Okay. So make sure you're using that vocabulary if they're talking about it being a line. And what they're going to try to do is they're going to try to go here and they'll say, oh, like this is like 1, 2, right? 1, 2. This one is 2 and a little bit, but they don't really know what that is. And they're going to say, this is 3 and a little bit. Oh man. 4 and a little bit. 5. Oh, we might say that's 5 and 7, but they're kind of guessing at what it is. But even if they get to this point, okay, you can talk about how that's a great strategy to use, finding the how they're changing, like how they're making the steps. Okay. Um, but one of the larger issues is the fact that over here, okay, you are not starting at 0, 0. Okay. All of our proportional relationships like this should start at 0, 0, the origin, just like how when we did our 2-line um, problems, we started with the marker 0, 0. That helps students to understand that they must start here, right at the corner 0, 0. If they start up or down, it's not a directly proportional relationship. There's something else going on. Okay. And so besides trying to find that, okay, have them point out initially that they didn't even have to try that because it didn't go through the origin 0, 0. So how do I know? Okay. I would say no, this is not proportional. because it does not pass through the origin 0, 0. And I would have them write the origin and the coordinate 0, 0, because I know they've been asked it both ways. And so they need to know that they're the same location. Um, and so have them talk about that. Also, because you did those word problems, it would be like, hey, if this was my like cost and this was my pounds, so if they need an example, you would say, well, at £0, if you're getting no ham or turkey, would you pay $1? And say that doesn't match what we've been talking about. It's a different type of relationship. Okay, it is important, but it's not going to be this constant of proportionality. All right, the next graph, okay, makes a curve. It's a smoothish kind of curve. Okay, um, it passes through 0, 0. Okay, because now they should be able to identify that for you. All right, so they'd say, oh yeah, great. But then you have to talk about this stair step effect. Okay, are they changing by the same amount each time? Okay, well, hold on one second. Whew. Excuse me. Um, so I can go here and I could guesstimate what kind of fractions these were at, but most likely you're going to pick 4 and 1. Okay, they might guess that this is 6 and 2, but it's not really. Um, I might say that this is like 7 and 3.5. All right, but are these the same? Okay, if I did 1 divided by 4, you might get the same value as 3.5 divided by 7. And you can have them work that out, okay? But you can say no and talk about how this would need to be a straight line, okay, to be proportional. So, no, it is not proportional. The line is not straight. And yeah, you can just talk to them about how straight lines are proportional. Well, it could be, right? Because you have to talk about origin. And curved lines are not proportional. But you kind of want to give them some examples, some values to go with it so that they know why it's not. Okay? We don't have any parabolic things, which would be really fun here. Okay? So I want you to write your examples for here and for here. And you're going to upload. And you're going to upload your answer keys for these two. Well, technically, you'll scan the whole page, right? Okay. And then there's some on the back, right? On the back, this is linking their tables to their graphs to the words we just did. Okay. So for on the back, there's only 3, so I'm going to do one with you. Okay. If you want to go ahead and pause, you can pause and you can set up your picture. So I'm going for 3, 2, 5, 4, 7, 6. Now then, if I connected my dots, if they don't have rulers in the room or something else straight, what I used to have my kids do was do this. So they'd pull their paper over and then think about playing connect the dots to the best of your ability. Okay. So when I connect these 3 values, did I make a straight line? Oh yeah, pretty straight. Okay. It just my drawing might not be perfect, right? But what's the bigger problem? Do I pass through the origin 0, 0? No. Okay. Also, I could go backwards here, and I could go 6, 4, 2, 0. This would be, what is this? Minus a 2. So 3, 1. So I don't have the point 0, 0. I would have a point 1, 0 if I was filling in my chart. to find out if the 0, 0 exists. So you would say, no, it does not pass through the origin. Okay. And again, you're going to upload these two here. Okay. My next graphing page says identify the constant of proportionality for each graph and write the proportional relationship y equals kx. So we've already done some of this with the other worksheets, but this is just to reinforce with only a graph, okay, what this looks like. I'm going to pause for just 1 second. Right? So on these graphs, what I would have the students do first is just scan them. Say, are these even representing these directly proportional relationships that would have a constant of proportionality? So they should scan and say, oh, origin, 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 origin. We are linear or a straight line on all of them. So we're good to go. All right. So to find the constant of proportionality, it's like the slope. Okay, it's going to be your y divided by your x, okay, equals the constant of proportionality. That's slope, okay, y divided by x. So here, okay, I'm going to find my coordinate that I like the best that's at a nice, neat intersection. So that's here, okay. My y value is 2, my x value is 1. Okay, I can already assume that the rest of these follow the same pattern because it is a straight line and it passes through 0, 0. So they don't have to check all of them. If you wanted to have one partner do one value and the other one do the other, they could. They'll just have to make sure that they reduce. Okay, so I would say that my constant of proportionality, okay, is 2 divided by 1, which is just 2. Again, I'm passing through 0, 0, so my equation would be y equals 2x. And we are using x and y because that's what the axes indicate. The next one here, okay, again, you do y divided by x to get the k value. Oh, good, I have another 1. That makes my life easier. Okay, so I'm going to say that k is equal to my y value, 7, divided by my x value, 1. Well, 7 divided by 1 is 7. Okay, so my k is 7. So my equation is y equals 7x. All right, now things are a little bit different here, right? And that's okay. Try this one real quick. Pause me. Right? So notice that there's no 1. All right. When I do my math and I have to say, I'm going to use these guys right here because they're a nice, neat intersection. Okay. I would say my constant of proportionality is my y value, 4, divided by my x value, 9. Well, 4 divided by 9 doesn't reduce. So it is what it is. It happens to be a fraction. It's fine. We'll move on. Okay. So it's going to be an equation y equals 4 ninths x. But again, oftentimes right now we're going to be using these whole numbers for what our students are working on. They're not necessarily going to see very many fractions yet. Okay. I would like you to do 4, 5, and 6. Upload key. 4, 5, and 6. And technically your whole page should be completed. Okay. This worksheet simply has them go in a different direction. Okay, so if you have students who need more of a challenge, having them draw them out is much more challenging than you would think it would be. And so you can do an extension with this. Okay. But the more important part that I'd like you to go over is the interpreting the graphs of the proportional relationships. So after you've done some work with just basic graphs, we're going to add in everything all together. Okay? So this one says interpreting graphs of proportional relationships, fill in the blanks to determine what the points mean in context. Okay, so that means in terms of the situation. It says the graph shows the proportional relationship between the time Evelyn and her friends spend sailing, x, and their distance from shore, y. What does the point 1, 4 represent? I go here, 1, 4. Well, 1 is the hours, 4 is the distance. So let's see, let's fill in these blanks. After 1 hour, Evelyn and her friends are 4 miles from shore. Please have them read this out loud with their partners because it's important that they really understand how to write out these sentences. Next is what does the point 312 represent? 312. So 3 is down here. It's going to be time in hours. So after 3 hours, Evelyn and her friends are 12 miles from shore. Take the time to also point out these are linear, making straight lines going through the origin 0, 0. So that you're just reinforcing that proportional relationship. Okay, you're going to upload answers for these two. Okay. Unfortunately, I won't be able to make copies today because nobody's in the office right now. But we'll get these to you on Tuesday. It'll be part of what you can come pick up. Okay. Right. And then on the back, we have the same thing. Okay. And again, I'd like you to work through these. Okay. I'll try to post these online in just a few moments after I've done recording these videos, and they'll have copies for you to pick up. All right. These should take you more than one class period to do with the students, so please don't try to do them all in one class period. I just want to do this all in one video so that it could be done and uploaded for you guys to get these sections uploaded for your answer keys. And if we need to do a discussion post on it, we will, but I don't think we need one for this. All right. Thanks a lot. Bye-bye.